Hello, SoloCon. This is Gert-Jan Gronings from Waylay speaking. We are here in Ghent, and I'm glad to be speaking on SoloCon. Hope you're having a good time. We're here to talk about how Waylay integrated the API gateway of Gloo onto our on-demand platform and also our other enterprise production platforms. To go over our talk, short introduction by me, and then there's a second part, a technical part, which is taken up by Olivier, my colleague who is sitting next to me here. So, introduction. We are Waylay, founded and still residing in Ghent currently. We are an IoT automation and data analytics platform. And we provide actually a rules engine. So that's a bit the central figure of our platform, which can be used to define complex logic on data coming in from your IoT devices. You could, for example, create some machine learning models, and from those machine learning models, calculate predictions on which you could act. Sorry. A bit of a dry mouth. So next up, this is our team. So our team is currently still growing. This is definitely already an older picture by now. So we're in full growth as we speak. To give you some idea of our platform, here are some numbers. So 500,000 of connected devices. And another number I can give is, for example, 313 million API calls that trigger about 1.5 billion serverless functions, which is 35,000 per minute. So yeah, we're quite busy. The people, our clients, are quite busy on our platform. To go over our architecture. Here's an overview. Important to note here is that we have multi-tenant and single-tenant components. That is all we are mainly focused on Google Cloud, though we are cloud agnostic, so we can, of course, deploy this in Azure or AWS. As we were early adopters also of Kubernetes, we are using Google Cloud. And currently, or we used to be we used to use the Google Cloud Load Balancer together with the Kubernetes ingress controller. But that's something that we also wanted to move away with. We wanted to go into more complex routing way. We wanted to have that unified API gateway, for example. Next, I will go a bit into how we used to do things. So it started off even before using Ansible with having virtual machines and pulling our code base in and putting it live on the spot. As soon as we had some tenants, we automated this through playbooks and different virtual machines. But already mentioned, we were early adopters of Kubernetes. So we moved all our config to Helm, and from there, centralized config was pushed to the Kubernetes cluster, both for our multi-tenant and single-tenant components. There was still something missing there because, of course, a tenant doesn't only consist of Kubernetes resources. There were also some cloud resources. So to connect all those things together, we went into our third phase, we could say, and that was where we adopted Terraform to hook into also any cloud provider necessary to do things all on the fly. And our fourth stage, you could say, is where we actually go into the need of this API gateway, or at least one of the needs, but that was our developer platform. So we call it Waylay IO. What is it? It's a true software as a service platform. Easy sign up, you start, and everyone can join in and create their rules on data that is coming in for them. Create a community, get some feedback, advance the product. How did we do this? We gathered all this information of past experience of deployment ways. This last part of Terraform, we actually made this available over a REST interface, and that's what we christened the tenant on-demand deployment, or TOD, as we call it internally. Then we, of course, because we had this on-demand deployment, we also went into a usage-based billing process. So we needed to have information of those tenants. It was important that whatever was happening automatically gave us some feedback. Also that this platform was seen as a platform. So a unified gateway was one of the requirements of that API gateway, where the users would talk to one API and not to components left and right. Don't need to know the specifics of what is happening in the background, just have the nice spec. We needed speed, we needed to scale. We needed to delegate authentication to the edge, to the API gateway and not on the components. We need to rate limits and also create some plans within those rate limits. Metrics was very important. How can we retrieve information from one tenant who is calling a multi-tenant component? So those were all problems that we wanted to solve. Of course, intuitive config, we, as everyone else, don't like when config gets messy and is not easily readable. Then also extensive traffic management, seeing we have this single tenant and multi-tenant setup. How versatile is this API gateway gonna be, cloud native, and then of course tracing for the future. So next up, we went into research. We, out of that research, gave points and went into 2 candidates that came out of there, of which one was Gloo. And of course, Gloo came out as the winner. So the clear reason was it met all the requirements, great articles even before we tried it. While we did the trial, we already got super great support. There was a Slack channel open, so it felt like we were already involved, and adoption came from both sides, let's say it like that. The documentation was great, and I think one of the also greater things was that it was based on Envoy, which is heavily maintained, so it's active development and wide adoption. And I think this is the part where I'll give it to my colleague, Olivier.
Hello, everyone. Thank you for this nice introduction, Gert-Jan. I'll continue with 4 topics which are more related to the technical part and how we got working with Gloo, integrating it into our Waylay IO platform. The 4 topics I want to discuss are authentication, rate limiting, metrics, and claim-based routing. So let's start off with authentication. So here on this figure, you can see the flow or different stages a request typically goes through when arriving at Gloo. So for authentication, I'll focus on the external out stage, as we have a very strict requirement that all our bots and thus requests have to be authenticated. Not only our user requests, but also inter-microservice traffic heavily relies on authentication and authorization features. So we have 2 options. Requests can either have basic authentication, so basic API key secret pairs, or requests can be authenticated using JWT tokens. For the API key secret pairs, we used to have a legacy component doing the exchange for JWT tokens, appending them to the request before forwarding them further on to the other microservices. But using Gloo, we had the perfect opportunity to deprecate that service and to move the functionality straight at the API gateway level by implementing an external out plugin. This plugin uses the provided Golang SDK and is loaded in the external authentication server upon startup. And it allows us to use or move our own business logic straight into the Gloo API gateway. This has the advantage that we have a very lightweight and simple approach to do the exchange, and we don't need an extra network hop or an external service we need to maintain to do JWT token fetching. Quick side note, the external out plugin provides an ideal opportunity to implement or to have some extra business logic into Gloo, even if it's completely not authentication related. We also played around a bit with that to have some extra features. But before going to production, we left all of that code out because everything we needed was already provided by other stages. So a brief overview of how a request comes into the authentication flow. So it arrives either using basic out, so API key secret pairs, or a JWT token. In the latter case, the plugin just forwards the request to the validation stage, which does a validation of the token based upon keys using JWKS URL for our remote authentication service. When API key secret pair is provided in the request, the basic out, the external out plugin, will fetch a token from the Waylay out service, and we can even implement some caching, so we don't need that extra call every time. In case there's no authentication provided at all, or the API key secret pairs are invalid, the response code will be in unauthorized or 401 status. The same goes for the validation stage if it fails. Another reason we heavily rely on this JWT structure is we include the tenant identifier in each token. So this provides me with the perfect segue to the next part, rate limiting, which is most commonly used to protect underlying services and resources. But we found this functionality extremely useful to implement user quota depending on their subscriptions. As Hertjan already mentioned, for the Waylay.io platform, we have different tiers, each with their own limitations on how much requests they can do and other criteria. So for this, we use the rate limiting functionality built into Gloo. And how do we do this? As I mentioned, we have for each request a tenant identifier, and we couple this with the rate limiting setup of Gloo. So on the left side, you see a very basic fictional example of a JWT configuration. And at the bottom here, you see the claims to header step, which will extract the tenant claim from the token and append it as a header with key tenant identifier to the request. This allows us to use it in our rate limiting config. So on the right side, where we describe some descriptors, for example, here a tenant descriptor with an associated rate limiting usage and time frame and an optional value. And there's also an action which couples the tenant identifier header key to the descriptor we define here. So basically, this allows us to rate limit tenant requests based upon their usage plan, which is a really nice feature for us as it couples nicely into our platform, and it didn't require us to write extra services to take care of that. So it's nicely built into Gloo. One thing to note is at the moment, we don't have the possibility to use the leaky bucket algorithms. So it's mainly time window based. So on each minute, hour, day, or other time frame, the counters reset, but that's not a real issue at the moment. It's a really small and basic example, but it's really powerful. For example, it's possible to extend the rate limiting configuration with extra descriptors or even child descriptors. So for example, we could set up a rate limiting config where each of our microservices has an upper bound, which is completely different than the global tenant upper bound a time frame can have. In the same context of usage-based subscriptions, it was also a big requirement for us to keep track of how many traffic a tenant generates upstream and downstream to our services. And Gloo via Envoy already provides a lot of metrics out of the box. There are some categories displayed here. There are a lot and really a lot of metrics available for the whole gateway, but also on an upstream level per HTTP status code and so on and so on. They're there at your disposal, but each use case obviously requires their own specific metrics. Gloo adds some more specific ones on top of Envoy and also comes with some nice auto-generating dashboards in Grafana to easily discover your data and to get you up and running. So as I mentioned, it's important for us to track the up and downstream traffic for each tenant on our platform. And we do this using the built-in metrics. Set metrics for up and downstream traffic are automatically generated out of the box per upstream, which means we need to create for each tenant, for each service, an upstream. Gert-Jan already mentioned that we want to streamline the user experience, and we just want one generic universal domain name for all tenants, for all users, namely api.io.waylay.io. So we certainly didn't want to have subdomains, different paths depending on the tenant, and so on and so on. No, one domain. Okay, no problem. But we have multi-tenant and single-tenant components. So this would mean that for the single-tenant components, we have a one-on-one relationship between an upstream and our Kubernetes service. But for the multi-tenant components, we would have a many-to-one relationship between these upstreams and these Kubernetes services. Okay, this led to the following setup. We create tenant namespaces inside of our Kubernetes clusters with their upstream configuration and also some other config and services. And we replicate this for each tenant. So as our tenants grow, our namespaces grow, and the number of upstream configuration grows as well. This results in the following diagram. So our single virtual service will have a lot of routing arrows, so to say, to the different namespaces for the respective upstreams, so the Waylay services can be reached. This, however, doesn't really scale well. So for example, imagine we have 1,000 tenants. This would mean we have arrows, or routing decisions based on, for example, a header value or other criteria to all those different namespaces, and those are evaluated in order, which we really want to avoid because it's not very effective. So this is not the way to go. Luckily, we could take advantage of a more recent introduction or new recent feature, and that is routing based upon a cluster header. So here we see a small example on how we do this in practice. So at the top, you see again the claims to headers code block, which results in extracting the tenant claim from the JWT token into the tenant identifier header. We also used this earlier on for the rate limiting configuration. At the bottom part, you see that we do a transformation. This transformation will use the tenant identifier and will create an upstream header, a header with the key upstream, and the value will be of the form upstream name underscore upstream namespace. And this is the schema Gloo and Envoy use to designate an upstream without using an actual upstream reference name and reference namespace. So in the middle part, you see a route action, and here we just refer to the upstream header using the cluster header key. And this allows us to dynamically at runtime let Gloo decide which upstream the request should be forwarded to. Do note that we have the clear route cache set to true, and that's because incoming requests already get a path assigned to them when they are evaluated at this stage. So we definitely need to reset routing cache so that the upstream header that is set here will be taken into account when doing this evaluation. Okay, so this results in the following diagram. So we have our virtual service using a single domain name as we required. And then we have an identified amount of namespaces. So it doesn't really matter how many we have. It scales perfectly with how many we have. It's just a mapping using the cluster header, which designates the upstream we require for a set tenant based upon the information we include into that header at runtime. And then those upstreams correlate to their respective Kubernetes services in the backend. So this allows us to have a per tenant, per service upstream, which results in metrics for up and downstream traffic for all of our tenants, and that satisfies the requirements and does the naming dynamic claim-based routing. Okay, so we have now authentication, rate limiting, claim-based routing, and metrics per tenant. And this all came nicely together, starting with our authentication, where we require each request to have a JWT token, as that includes our tenant identifier. This tenant identifier allowed us to do rate limiting on the amount of requests a certain tenant can invoke per time frame to our Waylay IO platform. It also allowed us to do claim-based routing, so we have a very generic and easy configurable configuration for our route tables and for our virtual service and upstreams. And then lastly, it also allows us to have metrics on up and downstream traffic per tenant, which was also a very important requirement. Okay, so how do we manage all of this? So first off, we use the Gloo Helm chart as a child in a custom chart we created together with, for example, Cert Manager for our TLS certificates, some secrets, some JWT configuration, and some other shared configs. And this allows us to quickly and easily deploy Gloo on a new cluster, pre-configured with all of our custom quirks we wanted to have, for example, also the external out plugin, and so on and so on. Then we have our Helm chart, which contains our API definitions. So basically, that's just a Helm chart with some Gloo-specific CRDs. So for the virtual service, it contains CRDs for the route tables, and then some other more generic upstreams we need for our services. This also allows us to make it very generic, which has the advantage that if we want to do an API update, we don't have to change all tenant configurations and a whole bunch of namespaces. No, we have one chart, one release where all our pods and route tables are defined, which is really sweet to do updates, to quickly iterate, to do versioning of APIs, and so on and so on. So that's a real big plus point for our deployment. Then the tenant-specific configuration is, as Gert-Jan already mentioned, created whenever a tenant is also created or registered. So together with some more account and more Waylay-specific actions, there are also some upstream CRDs which are created in the tenant namespace that allow Gloo to route incoming requests dynamically to a new tenant without even having to update the Gloo deployment or the Helm chart, which is listed as the second point. So this is also really powerful and does the naming dynamic claim-based routing. And then lastly, we have the rate limit config. That one contains our subscription models. So at the moment we have 3. And they contain the quota a tenant has for each microservice and globally, and tenant information is added to that rate limiting config whenever they are created, or it's also possible to update them as well, of course. Okay. So this was a quick overview of how we got started with Gloo, only I think now it's a bit more than 2 months ago, and how we got actually up and running very quickly and achieved all our requirements together with a little help from the Gloo team when we needed some support. Then, of course, there are still some things on our roadmap as we just have met our own requirements, but it's far from ready. So a few things that we want to check out next is federation and high availability. For example, at the moment, we only use Gloo on a cluster-specific level, so we don't do federation between clusters, and we don't have a high available setup on that part, but it's definitely something we're going to look at next. Also, alerting and monitoring is up next. For example, it would be nice to have some alerting whenever rate limiting quotas are exceeded, or for help monitoring, and so on. And then, of course, canary routing is also a very nice thing we'll have to look at next. For example, whenever releasing new releases, we can do some gradual changes of the routes and see if everything goes well. And that, of course, also comes together nicely with the alerting and monitoring. And also for internal routing, we can do some couple it together with the claim-based routing to do some internal redirects to the canary releases. And then last, we have the outlier detection and also fault injection to harden our services, to test, to do help monitoring, and to make sure everything is up and running and working fine. So that brings me to the last slide. Thank you for your attention. Thank you for listening through me babbling, and I hope you found it a good talk. And in case you have some more questions, or if you want to reach out, get to know what we do at Waylay, play around with our platform, feel free to reach out. You find our contact information below. We also have some videos, some white papers for you to follow along. And if you have any more questions, let us know. We'll be glad to try and answer them. Thank you.